Hi, and welcome to a video on the fundamental theorem of calculus. In this video, our goal will be to use the fundamental theorem of calculus to find the derivative of a particular integral. So before we do that, let's review the fundamental theorem of calculus. Part 1 of the fundamental theorem of calculus says if you take the antiderivative of a function, we're going to call that little f of t dt, and you evaluate that from a to x, you're going to end up with another function, the antiderivative, called big F of x. And this happens if f is continuous from a to b. If we take this a step further and we examine the derivative of the left side, so the derivative of big F of x is going to equal the derivative of our integral. Essentially, a derivative and an antiderivative, or an integral, are inverse operations. So these two things are inverse operations, and since we're using an x value, we're going to plug that in. And the derivative of big F of x is going to equal little f of x. We're going to get a little more into this into the next example. Before we get to that next example, let's take a look at part 2 of the fundamental theorem of calculus. Now, we're still talking about our little f and our big F, so if little f is continuous at every point on an interval, a closed interval from a to b, and big F is any antiderivative on the closed interval from a to b, then we know that the integral from a to b of little f of x dx is going to equal big F of a minus big F of b. And this can be investigated more in depth using area. We're not going to get into that in this video. We're going to get into how to use this part 2 of the FTC. One thing you should know is this part 2 is also called the integral evaluation theorem because you can evaluate definite integrals with this theorem. So let's go ahead and look at an example. The example we want to investigate is, let's find the derivative of this integral from negative pi to x of cosine of t dt. In order to do this, let's first look at what's inside the parentheses and let's evaluate that. We know the antiderivative of cosine t is sine t, and we need to evaluate that from negative pi to x. That's going to result in sine of x minus sine of negative pi. At this point, we're going to kind of leave this alone. We're going to plug it back into here, and we're going to take the derivative. When we apply the derivative operation to this expression, we know that the derivative of sine x is cosine x, and the derivative of this term is going to be 0 because this term is a constant. It doesn't really matter what the constant is. We're going to be a little lazy and not even evaluate it because the derivative of constant is 0. So we result in cosine x. Now if we go back to our example and examine that a little bit more closely, if we had taken the derivative and the antiderivative and canceled those because they're inverse operations and taken our x and plugged it in for the t, we would have resulted in cosine x, which is exactly the result we got when we did this the more complicated way. This is a really nice shortcut that we're going to be able to apply to other problems that you're going to see.